Assalamu alaikum. Hello everyone. Today I am going to discuss with you some problems from mechanics. These problems I got from the books approved by NCTP, National Curriculum of Bangladesh. And these books are from high secondary levels books, mathematics, high secondary higher math books. So first problem is, if the square of the resultant of two equal forces is equal to the thrice of the product of that two forces, then find the angle between the forces. Let R be the resultant of the two equal forces P and P, which are acting at an angle alpha at the point O. According to the question, here R square is equal to 3 times P, which is 3P square. So 3P square is equal to P square plus 2P square cos alpha. From here we find R square, P square is equal to 2P square times cos alpha. So cos alpha is equal to 1 divided by 2. So cos alpha is equal to cos 60. So alpha is 60 degree. Now second problem, here in this problem, if three forces P, Q are of scenario 1 are in equilibrium, then we have to prove that these all are equal. So here given that the point O is the circumcenter of ABC triangle and the forces P, Q and R act along OA, OB and OC respectively. Since the forces are in equilibrium at the point O, we find by Lami's theorem that P by sin Q R, Q by sin P R, Q by sin RP and R by sin PQ. But in BOC triangle we have on the same arc central angle BOC is equal to 2 times angle at the circumference. So BOC is equal to twice A, and QR, so QR is equal to twice A. Similarly RP is equal to twice B, PQ twice C. Okay, now from 1 we get P by sin twice A, Q by sin twice B, R by sin twice C. So P by 2 sin A cos A, Q by 2 sin B cos B, R by 2 sin C cos C. And we can substitute a sin A by AK, sin B by BK, sin C by CK from this formula. So P by A cos A is equal to Q by B cos B is equal to R by C cos C. From there we can substitute cos A by B square plus C square minus A square by 2 base C, and cos B by C square plus A square minus B square by 2CA, and cos C by A square plus B square minus C square by 2AB. So P by A square times B square plus C square minus A square, Q by B square times C square plus A square minus B square, and R by C square times A square plus B square minus C square. This all proved. Now next in if the forces P, Q are both increased by S and the resultant is displaced from the point C to D, then we have to show that CD is equal to S by P minus Q times AB. Okay, so here to unlike parallel forces P and Q, where P greater than Q act at the point A and B respectively, and their resultant P minus Q acts at the point C. Applying proportion law of unlike forces, we get P by BC, Q by AC and P minus Q by AB. Taking second and third ratios, we get Q by AC and P minus Q by AB. So AC is equal to Q times AB by P minus Q. This is equation 1. Again, if both the forces P and Q be increased by magnitude S, then their resultant P plus S minus Q minus S, that is P minus Q, moves aside at a distance D unit from the point C and acts at the point D. Okay, so P by P plus S divided by BD, Q plus S divided by AD, P minus Q by AB. Taking second and third ratios, we get Q plus S by AD is equal to P minus Q by AB. So AD is equal to Q plus S times AB by P minus Q. By subtracting 1 from 2, we get AD minus AC is equal to Q plus S times AB by P minus Q, Q times AB by P minus Q. So D is equal to S times AB divided by P minus Q. Okay. Now here, if a particle is projected with the velocity u at an angle alpha to the horizon, then we have to prove that the greatest height h is equal to u square sin square alpha by 2h g. So here a particle projected in the space from the point O with an initial velocity u at an angle alpha with the horizon reaches the highest point A. So at the point of the horizontal component of u is u cos alpha and vertical component of u is u sin alpha. So the greatest height is h. Since at the greatest height the vertical component becomes 0, we get 0 is equal to e square sin square alpha minus 2gh. So h is equal to e square sin square alpha by 2g. So greatest height is h is equal to e square sin square alpha by 2g. Okay. Now third problem. In scenario 1, if a swimmer requires t seconds to cross AB distance at t prime seconds to cross AC distance, we have to show that t is to t prime is equal to root over u plus b is to root over u minus b. This is the scenario 1. Here we can see that v is across the v acts across this line and u acts across this line. So u and the angle between u and b is alpha. So w, the resultant w is equal to root over a square plus b square to v cos alpha. Now taking result part of the velocities along direction of v, we get v cos 0 plus u cos alpha is equal to w cos 90 degrees. So v plus u cos alpha is equal to 0. So cos alpha is equal to minus v by u. So w is equal to root over e square minus v square. Okay. And in first case, the swimmer directly crossed the river AB is equal to d with resultant velocity root over e square minus b square in time t. So d is equal to root over e square minus b square times t, which is equation 1. Second case, the swimmer swims at the distance AC equal to d down the stream with velocity u plus v in time t prime. So d is equal to u plus v times t prime. This is equation 2. From 1 and 2 we get these two are equal. So from there we get t is to t prime is equal to root over u plus v is to root over u minus v. Find the horizontal, we have to find the horizontal range of the projectile. Let the body is thrown from the point O with velocity u at an angle 45 degree to the horizon, and it somehow passes two walls of the height 4.5 meter which are at a horizontal distance x from the point of projection. So we have, by applying the formula equal to 10 alpha x 10 alpha times 1 minus x by r, we get 4.5 is equal to x 10 45 degree times 1 minus x by r. So 9 by 2 is equal to rx minus x square by r. Here the roots are x1 and x2, so x1 plus x2 equal to twice r by 2 is equal to r, and x1 x2 is equal to 9r by 2. So AB is equal to root 2 times root over 10 meters. X1 minus x2 is equal to 2 times root over 10. Squaring both sides, we get x1 plus x2 whole square minus 4x1 x2 is equal to 40. So here we get r square minus 18r minus 40 is equal to 0. From there we get r minus 20 times r plus 2 is equal to 0. So r is equal to 20 or minus 2. So since r is equal to minus 2 cannot be taken, so r is equal to 20 meter is our range. Here another problem. A hawker places a stick horizontally on his shoulder and a load at the end of the stick. If the weight of the load is 12 kg and if 2 meter and 3 meter are the distance of the load, the shoulder and the load at the at the end of the hand respectively, then we have to find the pressure on the shoulder. The shoulder, if we think the shoulder on this point, then the length of the stick is AB, the weight of the load is 12 kg at the end B of the stick. So this load acts at the end, this end, okay, this load acts on this end, and position of the shoulder is at the point C, and the man is carrying the load by applying the downward pressure at the end A by his hand. So BC is equal to 22 meter, AC is equal to 3 meter. If the total pressure on the shoulder is R, then R is equal to 12 plus P. Applying the proportional law of like parallel forces, 12 by AC, P by BC, and R by AB. Then we get from first and second proportion, 12 by 3 is equal to P by 2. So P is equal to 8. So total pressure on the shoulder is 20 kg. That's all for today. I hope these problems will help you to understand the topic easily, and please subscribe my channel and give me your problems, and then I will try to solve in my next video. Allah Hafiz, hope you all the best.